Good morning students. So, in today's class I am going to discuss on KVL, so that is Kirchhoff voltage law. So, here in this Kirchhoff voltage law, so it is also called as loop rule. So, we have studied the KCL, Kirchhoff current law, that is also called as node rule, but whereas second law of Kirchhoff is known as Kirchhoff voltage law, it is also called as loop rule. So, it is in short we call it as a KVL. So, what is this statement, KVL statement? So, it states that the algebraic sum of EMFs in a closed loop of an electrical network is equal to algebraic sum of IR drops in that network. So, any of loop you consider, in that loop how many number of EMFs are there, their algebraic sum is equal to algebraic sum of IR drops. IR drops means what? There is a voltage drop across each resistors takes place. So, they are called as that voltage drop itself, we call it as a IR drops. So, that IR drops, their addition or algebraic sum, that is equal to algebraic sum of your EMFs. So, that is called as your Kirchhoff voltage law. So, it states that here, it states that Kirchhoff voltage law, it states that the algebraic sum of EMFs, algebraic sum of EMFs in any closed loop, in any closed loop of a electrical network, is equal to algebraic sum of IR drops in that loop. So, this is the second statement of Kirchhoff, that is called as KVL. So, here only voltages are going to be considered in this statement. So, that is nothing but it states that the algebraic sum of EMFs in any closed loop. So, we have already come across what is a loop. So, how many number of EMFs are there? They are going to be added together. So, that addition or algebraic sum is equal to algebraic sum of IR drops in that loop. So, that is in short we can write it as summation of EMFs. EMFs means electromotive force. Algebraic sum of EMFs is equal to your algebraic sum of IR drops. So, that is algebraic sum of EMFs equal to algebraic sum of IR drops. So, then this statement we call it as a KVL or Kirchhoff voltage law. For this, so let us consider one electrical circuit that consisting of two resistors, resistive network circuit, let us consider that one. Suppose assume that here two resistors R1 and R2 are there. So, they are going to be connected to your EMF of voltage E here, EMF of voltage E. So, that is going to be connected in the circuit, or let that be voltage be V voltage. So, then what happens? Whenever as soon as this power is turned on, current starts flowing in the circuit, this one is positive and this immediately current starts flowing in the circuit. So, when current flows here, then IR drop takes place across R1. IR drop means the product multiplication of your current into R1 is voltage drop V1. So, this is a voltage drop V1 appears across R1. Similarly, current also flows, the same current flows through R2 also. There is also voltage drop, that voltage drop we call it as a V2 voltage drop. So, this V2 voltage drop, it appears across R2. voltage ಏನಾಗ್ತದೆ ಡ್ರಾಪ್ ಆಗ್ತದೆ ರೆಸಿಸ್ಟರ್ನಾಗ. ಸೊ ವಾಟ್ ಎವರ್ ವೋಲ್ಟೇಜ್ ಯು ಹ್ಯಾವ್ ಅಪ್ಲೈಡ್ ಟೋಟಲ್ ವೋಲ್ಟೇಜ್ ಇಟ್ ಡ್ರಾಪ್ಸ್ ಇಂಟು 2 resistors are there. If no resistors means same voltage is maintained, but whereas here 2 resistors are there means one voltage drop across R1, another voltage drop across R2. That means that in a series combination what happens, the voltage divides but current remains same. Because of that IR drop, why we call it as IR drop means I into R and I into here also current flows I into R2 itself, multiplication is nothing but V2, that is product. So that product itself we write it as here IR. So that is sum of EMFs. How many EMFs are there here? EMF is nothing but V. Sum of EMFs is equal to, here in this circuit EMFs, algebraic sum of EMFs, algebraic sum of EMFs means here in this circuit, entire circuit only one EMF is there, that EMF is nothing but V. So this V is equal to, no one another EMFs are there, so we can write only one EMF voltage as V. So that is equal to algebraic sum of IR drops. Since there are 2 resistors are there, 2 IR drops are there, so that IR drops are nothing but current into R1, first IR drop, and next one is another current into R2, IR2. So that is algebraic sum of, this follows the statement of algebraic sum of EMFs is equal to algebraic sum of IR drop. So that is V is equal to, IR is how many, 2 resistors are there, therefore here IR1 and plus IR2. So that is nothing but V is equal to, we can write it as V1 plus V2. So that is, it is nothing but a voltage law. Kirchhoff law is a voltage law that is applicable only for as concerned for your voltage. So what is the voltage? Voltage is nothing but it is the charges or energy that is going to be performed. Energy either it going to be gained or it going to be lost. So that is nothing but energy gained or lost per unit charge is called as voltage. So that means that this KVL, it is based on the law of conservation of energy. So here previously KCL is based on the law of conservation of charge, but whereas here this KVL, it is based on law of conservation of energy. Law of conservation of energy. Since we know that no energy, neither of energy can be created or nor of the energy can be destroyed. Conservation of energy, where voltage is, we define it as, what is the voltage? Voltage is defined as energy per unit charge. So where voltage is defined as energy per, that is energy is nothing but here electrical energy, energy per unit charge, energy per unit charge. So according to this statement what happens here, the total amount of energy gained in the circuit per unit charge, here EMF is nothing but gaining the energy. Total amount of energy gained per unit charge is equal to total amount of energy lost per unit charge is nothing but this statement of KVL. So that is KVL states that the algebraic sum of EMFs in a closed circuit or in a closed loop of any of your electrical network is equal to algebraic sum of IR drops in that loop. So this statement KVL, it is based on the law of conservation of energy. So because your voltage is defined as energy per unit charge, so therefore whatever the total amount of energy is gained per unit charge is there, so this one, that is equal to total amount of energy lost per unit charge. So because of that, this statement is also based on your energy per unit charge, because it is a voltage law. So now this concept is here over. Now we have to come across, so our sign conventions, they are going to be used for simplification of various networks, electrical networks. For that purpose we need the sign conventions here. What all the sign conventions we are going to use there here? So next is sign conventions. Sign convention ಬಗ್ಗೆ study ಮಾಡೋಣ್ರಿ. So sign conventions means EMFs as well as voltage drops we are using. So early in KCL what happens? Sign convention, how it is taken? The current entering are taken as positive. Current entering at a node, all currents are taken as positive, and whatever the current they are leaving the node, they are taken as negative signs. So but whereas here for this KVL what happens? Sign conventions excuse. Sign convention andre enri. So we are writing the equations, mathematical equations. So that consists of your voltage drops and IR drops and EMFs. So while using that, what signs we should use? Mathematical signs, either it should be positive or it should be negative. So first one is sign convention of EMF. Sign convention of EMF. EMF is nothing but it is a DC source. That DC source is nothing but our cell or a battery here. So let us consider this cell. It is represented like this. EMF of E. So current flows in this direction, I current, and direction of conventional, direction of loop current, and one more concept is there. So that is here this battery is reversed or your cell is reversed in this manner, then current flows in this direction, that is conventional direction current. Here it is called as conventional direction of current, direction of current, and the direction of, here this one is direction of direction of loop current. Conventional direction of current and direction of loop current. Then here EMF E. So first convention here sign convention. ಯಾವಾಗ ನಿಮ್ಮ ಸರ್ಕ್ಯೂಟ್ನಾಗ EMF ಕನೆಕ್ಟ್ ಆಗಿರ್ತಾವ. ಸೊ ಇನ್ ದ್ಯಾಟ್ ಟೈಮ್ ವಾಟ್ ಕನ್ವೆನ್ಷನ್ ಯು ಶುಡ್ ಫಾಲೋ, ಹೆಂಗೆ ತೊಗೋಬೇಕ್ರಿ ಕನ್ವೆನ್ಷನ್ಸ್, ವಾಟ್ ಸೈನ್ ಯು ಶುಡ್ ಟೇಕ್ ವೈಲ್ ರೈಟಿಂಗ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್. ಸಮ್ ಆಫ್ EMF ಇಸ್ ಈಕ್ವಲ್ ಟು ಸಮ್ ಆಫ್ IR ಡ್ರಾಪ್ಸ್ ಅಂದೀವ್ರಿ. EMF ಹೆಂಗೆ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ತೊಗೋತೀವಿ? ಸಪೋಸ್ ಇಫ್ ದ EMF in a circuit is taken as positive. So EMF of a voltage source. So this is a EMF E. So this is a voltage source. If EMF of E of a voltage source, it is taken as positive. Idan positive and consider martivi. When it is taken as positive, if the direction of loop current, it is assumed direction. ನಾವು ಏನು ಅಸ್ಯೂಮ್ ಮಾಡ್ತೀವಿ? ಲೂಪ್ ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಅಸ್ಯೂಮ್ ಮಾಡ್ತೀವಿ ರೀ. ಇಫ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಲೂಪ್ ಕರೆಂಟ್ ಈಸ್ ಅಲಾಂಗ್ ದ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಆಸ್ ದಟ್ ಆಫ್ ದ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಥ್ರೂ ದ EMF of a cell. So that is nothing but the direction of loop current is in same direction as that of the current supplied by that EMF of source, voltage source. So whatever current is supplied, current ಯಾವಾಗಲೂ ಹೆಂಗೆ ಸಪ್ಲೈ ಆಗ್ತದೆ ನಾವು ಆಲ್ರೆಡಿ ಹೇಳೇನ್ರಿ. ಕನ್ವೆನ್ಷನ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್ ಹೌ ಇಟ್ ಫ್ಲೋಸ್ ಇನ್ ಅರ್ಲಿಯರ್ ಕ್ಲಾಸ್. ದ ಕನ್ವೆನ್ಷನಲ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್ ಆಲ್ವೇಸ್ ಫ್ಲೋಸ್ ಫ್ರಮ್ positive terminal of a battery to the negative terminal of a battery, means it starts from this direction, it starts from positive direction. So because of that this is considered as a direction of current supplied by the voltage source or EMF of that voltage source. So, that is same as that of direction of loop current. So, then it is taken as positive, EMF is taken as positive. So, EMF is also here, it is a opposite direction of EMF, cell is reversed, ಇಲ್ಲಿ cell reverse ಮಾಡಿವಿ. So, in this we take the EMF as minus E. So, direction sign convention for EMF is minus here, that is nothing but the EMF of voltage source is taken as negative if the direction of loop current is opposite to the direction of current that is going to be supplied by the EMF of that voltage source. ಈ voltage source current ಹೆಂಗೆ supply ಮಾಡ್ತದ್ರಿ? It supplies the current from positive direction. So, it flows in this opposite direction backward, but whereas direction of loop current is in this direction. Loop current ಹಿಂಗದ and current, conventional current is in this direction. That means that both the currents are opposite. When both the currents are opposite, so that EMF, this EMF itself is taken as minus E here. So, here both are in same direction, because of that E is positive. Here both are in opposite direction, because of that EMF is taken as negative. One more is the same sign conventions, they are applied for IR drops. IR drop antivi, sum of EMF is equal to sum of IR drops. So, IR drops ige, so while writing the IR drops product, so which sign we should use, whether positive or negative, depending upon the sign convention. Here also we should follow the rule here. So, sign convention for IR drops, so they are nothing but rules, they are to be followed while analyzing your electrical circuits. So, here sign convention for IR drops. So, IR drops means consider a resistor here. So, this resistor is there. So, along with that what happens, current flows in this direction, as well as the loop current is also in the same direction. The same concept here, loop current, direction of loop current and direction of current flowing through the resistor. So, direct IR drop means, IR drop is nothing but product of your current into resistance. So, here to find the IR drop, what sign should be used before this one, whether it is a plus IR or minus IR. So, for that purpose here, so if current is flowing through the resistor, so that is nothing but the current flowing through the resistor is, if it is in same direction as that of your loop current, whatever the loop current you are assuming in the circuits. So, that loop current, if that direction of loop current as well as current flowing through the resistors both are same, then that IR drop is taken as positive, positive IR drop. If the current flowing through the resistor, if current flowing through the resistor is in opposite direction, so that is opposite direction, current is flowing in opposite direction, but whereas our direction of loop current is in another direction, direction of loop current, both are opposite to each other. The direction of loop current and the current flowing through the resistor, or that is also called as conventional direction of current. So, this one is called conventional direction of current, that is going to be supplied by your EMF of a cell. So, if these currents, both the currents, they are opposite to each other, then we take that IR drop as minus IR. So, that is considered to be as minus IR. Idin ಏನಾಗ್ತದ್ರಿ sign conventions, while solving our KVL to the circuits, you come to know these conditions. So, you conditions ಹೆಂಗೆ apply ಆಗ್ತಾವ ಅನ್ನೋದು ನಿಮಗೆ understand ಆಗ್ತದ್ರಿ. So, these are the sign conventions, they are going to be usually employed in our electrical circuit analysis by using our KVL. So, this is the sign convention for EMF and IR drops. ನೋಡ್ರಿ ಇದು ಸೇಮ್ ಡೈರೆಕ್ಷನ್ಸ್ನಾಗ ಇದ್ರೆ ಪಾಸಿಟಿವ್ ತಗೋಬೇಕು. ಇಫ್ ಬೋತ್ ಆರ್ ಇನ್ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್, ದಿಸ್ ಕರೆಂಟ್ ಆ್ಯಂಡ್ ದಿಸ್ ಕರೆಂಟ್, ಲೂಪ್ ಕರೆಂಟ್, ಇಫ್ ದೇ ಆರ್ ಅಪೋಸಿಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಇಟ್ ಆಸ್ ಮೈನಸ್. ಸೊ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ಈಸ್ ಓವರ್. ನೋ illustration of our KVL ಅಂದರೆ ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಪರ್ಪಸ್ ಅಲ್ಲಾಗಿ ಒಂದು KVLದು ಸಿಂಪಲ್ ಸರ್ಕ್ಯೂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರಿ. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಎ ಸಿಂಪಲ್ ಸರ್ಕ್ಯೂಟ್ ಕನ್ಸಿಸ್ಟಿಂಗ್ ಆಫ್ 2 EMFs and 2 resistors. What all the sign conventions we have to use there in that circuit? Let us consider the circuit consisting of 2 EMFs here. So one EMF is called as E1. So this one is plus and minus. Here R1 resistor. Consider one more EMF here, plus and minus E2, and current I is flowing in this circuit. So plus minus. So here also one more resistor you consider in this circuit, R2, 2 resistors. So what all the sign conventions we should use in the circuit? There are 2 EMFs are there in this circuit. How to apply the KVL? KVL means how many loops are there in this circuit? KVL is nothing but loop rule antivi. Loop rule andra how many loops are there? Here only one loop. So that is algebraic sum of EMFs in any closed loop. So this one is closed loop here. So always loops directions, loop current directions are applied clockwise, or regularly they are applied as clockwise directions, and sometimes they may be used as an anti-clockwise direction. So if many of 2 or more loops are there, then loop directions, all directions of loop current should be either clockwise or it should be anti-clockwise. Ella one time ige en tagotivi, clockwise are consider ಮಾಡಬೇಕು, ಇಲ್ಲ ಅಂತಂದ್ರೆ anti-clockwise are. So here only one loop is there in this circuit. The circuit consists of one loop. So circuit consists of one loop here. Therefore sum of EMFs EMF is taken as positive. So the direction of current supplied, so this one I is nothing but I is the direction of current supplied by EMF, direction of current supplied by EMF, and loop current is also in the same direction. Loop current to ide same direction nagadari. So this one is called as loop current I. So I1 Henry, I and I1 both are in same direction. So then loop current, so this is a loop here, we are assuming the loop current direction in clockwise. Naven assume madbi loop current ee direction nag flow agtadri. So there is only one loop and only one branch, so therefore only one current flows, that flows in this direction, I1 like this. So this one is a loop current. I1 is the loop current. So see here, so I is the current supplied by the electromotive force EMF of a voltage source, and I1 is that is nothing but conventional direction of current. It is flowing in this direction, like this it flows, I flows in this direction and reaches to your negative terminal of battery. Similarly here loop current I1, it is flowing in this direction, it is also same direction as that of your convention, means assumption. So this one is loop current is nothing but it is a assumed direction of current, for our sake of convenience. Assumed direction of current, we have to assume one more current, so that is loop. So for that loop current flows, that current also flows in clockwise direction, it is flowing in a clockwise direction, current flowing in a clockwise direction. So like this. So then what is the direction of, there are 2 EMFs are there. So EMFs, whether they are taken as positive or negative, here E1 is taken as E1 is positive. Why? Because the current flowing here, the current flowing through the EMF as well as your loop current is also in this direction, clockwise. So that means that both are in same direction, loop current as well as current flowing through the battery or your source, both are in same, therefore E1 is taken as positive. One more EMF is there here. So, this current flows in this direction and it flows in this direction. That means that I flows in downward direction. Here it is in upward direction, current is in this direction, but your voltage source is opposite. Voltage source is opposite means the current supplied by the source must be in the same direction as that of your loop current. Here we are moving in a battery in opposite direction from positive to negative. Because of that, E2 is taken as negative here. So, current is supplied, actually what happens here, the current whatever is supplied because of this source is in opposite direction. So, our current flowing is loop current is flowing in this direction clockwise, and the current supplied by the battery is in opposite direction, because that E2 is taken as negative. Next, IR drop. So, IR drop is nothing but IR current flowing through the resistor, and current loop current both are in same direction, therefore IR1 is positive. IR1 is positive. Similarly, same direction of current flows here. This current flows in this direction from positive to negative here, voltage drops. So, therefore, it is flowing in this direction. That means that this direction of current and this current, loop current. So, this loop current and I both are in same direction. Therefore, IR2 is also positive. IR2 is also taken as positive. So, ಇನ್ನೊಂದೇನ್ರಿ easy method ಹೇಳ್ತೀನಿ ನಿಮಗೆ. So, instead of taking the rule of EMF, so simple method ಏನಂತಂದ್ರೆ, while moving in a network ನಾವೇನು ಮಾಡ್ತೀವಿ, ಲೂಪ್ ತೊಗೋತೀವಿ ರೀ, clockwise directionನಾಗ ಮೂವ್ ಆಗ್ತೀವಿ. clockwise-ನಾಗ ಮೂವ್ ಆಗೋ ಮುಂದೆ when negative terminal of battery while moving in this direction in a clockwise direction, when negative terminal of battery arrives first and then the positive terminal, that battery should be taken as positive. So, therefore, even EMF is positive here. One more is here, while moving in a closed path or while moving in a loop here, so first positive arrives and then negative of a voltage source arrives, then that voltage source must be taken as negative. So, this is a simple method. While moving in a loop, if, so that condition EMF hang togobekandra simple method ರೀ, while moving in a loop, if negative terminal of battery arrives first, if negative terminal of source or a battery arrives first and next positive terminal, that EMF is taken as positive, EMF, that EMF is taken as positive. While moving in a loop, if positive terminal of battery arrives first, positive bantandra, avag ಏನು ಮಾಡ್ರಿ, that battery EMF you should take it as negative. That is the simple method for assigning the sign for your EMF. That is a simple method. If you go by the statement of your sign convention that is given in textbook, it is a little bit complicated. Instead of that, in madri loop nega, when in which direction you are moving in a loop, so you are moving in clockwise direction, avag ಏನು ಮಾಡ್ರಿ, clockwise ನ move ಆಗೋ ಮುಂದೆ, so whenever battery positive terminal arrives, first positive ಹತ್ತಿತ್ತಂದ್ರೆ ಅವಾಗ ಏನು ಮಾಡ್ರಿ, that battery is taken as negative. So, same if you are moving, continue to move here, so negative first arrives here for this battery, so that means that this battery is taken as positive. So, these are the sign conventions, they are going to be employed in our electrical circuits for the simplification purpose, simplification of our electrical circuit. We require these sign conventions. So, one example is given here. example. Let us solve some example, then you come to know about these KVL and KCL statements, how they are going to be used in our electrical circuits. Calculate the current I flowing through the node N. Calculate the current I flowing through the node N. First here circuit is given, simple circuit consisting of only one node here, like this. I is equal to how much? Sorry. So this one is in this direction. I is equal to how much? And so this one is 3 ampere current and 2 ampere of current. N is the node here and this one is 2 ampere of current. Calculate I. So how to calculate I means, so here node and currents are there means you have to use the KCL, applying Kirchhoff current law at node A. So applying Kirchhoff current law at node A. So Kirchhoff current law, what it states? It states that algebraic sum of current entering at a node is equal to algebraic sum of current leaving that node. So here node is N here. So in this N, algebraic sum of currents entering. So current entering, which are the current entering here? There are totally 3 currents are there. So this one direction is given like this. So there are 3 currents are there. 3A is entering, I is also entering, means current entering. So how we write? According to our Kirchhoff current law, current entering equal to sum of current leaving. Sum of current entering is equal to sum of current leaving. Current entering. So this current I, 3A ampere current and I ampere current, both are entering at the node. So they are taken as positive. I is equal to 2A is leaving the node. 2A nag the node lind away move aglikatadri. It is moving away from the node. So it is taken at right side. Only one current is there. So write only one current. Now here I is equal to, if we bring this 3 on right hand side, then so this plus 3 becomes, it is minus 3. 2 minus 3 is nothing but I is equal to minus 1. So that is I is minus 1 ampere. So current flowing through the node is equal to minus 1 ampere. So this is a simple problem. So to understand the concept of here KCL understand ಮಾಡಬೇಕಾಗಿತ್ತಂದ್ರೆ sum of current entering is equal to sum of current leaving.